Hello everyone, so it's good to see y'all here again. I'm Natasha and welcome back. So today we're going to continue our chapter 2, Relations and Functions. So in the previous video, we discussed about greatest integer function, or which we can also say step function. And in this video we're going to discuss about algebra of real functions. So, before starting our today's topic, I want to tell you something else. So in this, we're also going to discuss about some other functions too, like odd function and even function, and some more. We'll discuss about some other topics also. Just after this topic, algebra of real functions. Okay, so let's get started. Okay, so first of all, let me write the main heading. It is algebra of real functions. Okay, yeah, so just let me write it in the mid. Algebra of real functions. So, real functions in algebra of real functions. So, real functions, like basically, it's related to, functions which are related to the real numbers. So, that's what I can say exactly. Just the real functions. As we have the real numbers, it's just same like the real function. Okay. Just the difference is that we're talking about functions, not the numbers. So, algebra of real functions. So, algebra of real functions involve addition, subtraction, multiplication, and division of real valued functions. So, first we're going to discuss about the addition of real valued functions. So, let me write. First, we're going to discuss about not the algebra I'm going to write just simply addition. As we're going to see the addition in real functions. Addition of real functions. So, addition of two real numbers. Okay, addition of two real numbers. So, first let's take an example, then I'm just going to write it all about it, okay? Okay, so in addition of two real numbers, like we're going to talk about the two numbers, and we will be doing their addition. So, let's say we have fx and gx, okay? So what I'm going to say that f plus gx is equal to fx plus gx. Okay, just have a look. This is what, we're basically going to do in addition of two real numbers. F plus gx is equal to the fx plus gx, okay, g of x. And one thing is that for all x belongs to, this x. So this x, I'm just going to say it's a function. So we have two functions. Let's say we have set r. The r for the real numbers, let's say, and x is just a function. I'm going to say, which basically, overall we're just talking about a set, okay? That's it. Okay, so I'm going to talk about two sets, or maybe two functions I can say for now. So x and r, x and r. So just have a look at this. So the function we're having, let's say f. F is the function. So f is a function from x to r, and g is a function from x to r. And one thing that we're going to say that this x is a subset of r, okay? X is a subset of r. So let's see. So what we're saying is that f function is from x to r and g is also from x to r. So like these two are real functions. And second thing is that x is a subset of r, okay? So what we can see in this is that it's simply talking about the two functions. These are the two functions, two real functions. Okay, f for x to r for the g, and two real functions where x is a subset of r. Okay, so two real functions. So these are the two real numbers. Sorry, not the numbers. I'm talking about the functions. So two real functions where x is a subset of r. So for the addition of any two real numbers, we're going to use this method. Okay. Well, it's like a formula. Of course, it's a formula that we're going to use while while we're having any addition of two real numbers. So while we're doing the addition of any two real functions, okay, the two real numbers. Okay, so addition is like really easy. So in which we had two functions f and g from x to r, and f and g were two real functions, and these two relations, or like function is a special kind of relation, and just we're going to talk about this in sets. So they're going to be where the x is a subset of r. That's it, nothing else. So it's just really simple addition. And yeah, later on we're going to solve a question also, so that we can understand all the concepts that we discussed. So second is subtraction. Second we're going to discuss about is going to be subtraction of a real function from another. Subtraction of a real number from another. Okay? Oh, not again. I'm going to write it again, so to make some relevant space. Subtraction of a real function from another. The subtraction of a real function from another. So it's just basically talking about the subtraction that we're going to have from a function to another function, okay? So let's take this same one. So in this one, our formula is going to be, let's say, f and g. So just at the place of this plus, we're going to put the minus sign, for the subtraction. As we're not doing addition, so, we're going to put the minus sign. Okay? So it's going to be f minus g x is equal to f of x minus g of x. So f minus g, like the subtraction of these two real functions. And this x is, remember one thing, that this x is just a symbol. This is just a symbol. So what we can do is, like, if we're given, if like another kind of thing is given at this place. So one thing that we'll always have to remember, that this is just a symbol. So we can just put that value on the place of it. Okay, it's just a symbol, nothing more than that. Okay? So is equal to fx minus gx for all x belongs to x. So this x is just, I'll say every element x in the set x we're having, okay? So just have a look, okay? Then after that, I'm going to take the same thing, okay? Okay, so let me just write. So I'm going to take the same sets f. So let function f, so it's from x to r, and g from x to r be any oh my gosh, okay, be any two real functions. Okay, so f is a function and g is also a function. So one thing that we have to remember, in x from x to r and from x to r be any two real functions. So these are the two real functions, and where I will need some space, so maybe I'm gonna write this a little small, okay? Yeah, just a little small. Okay. Yeah, so let's continue. Okay, x, where x is a subset of R, and I'm going to write this for all x belongs to x. Okay? Yeah, so where x is a subset of R, so then what are we going to define? So we're going to define that this f minus g, this is x from x to r. This is just like similar like this way, okay? And in this one too, just the same. It's going to be then f plus g, okay? Okay? One thing. Okay, so let's continue. So all these things are really easy things. So all these are really easy things. So the addition, subtraction, these were like really basic here. So and were really easy to understand about them. So let's move on to our third one. Our third one, that is going to be we have done addition, subtraction. Now we're going to do multiplication. Multiplication. Wait. Should we add something else, something extra? Okay, let's try adding what we can add. Let's talk about the scalar quantities. Oh, we haven't it's been a long time since I've discussed about this topic. Scalar. So scalar quantity. So we're not going to discuss about scalar quantity. We're actually going to have a look at the multiplication by a scalar. Okay? So we're going to do the multiplication by a scalar. That's interesting. This is interesting. It is. Let me just mark them, underline them. So, okay, whatever. Multiplication by a scalar. Oh, that's kind of interesting. Let's have a look. So multiplication by a scalar. So first of all, I'm going to write the formula right here, and then we're going to talk about a scalar. So let's say the scalar I'm going to take is going to be alpha. I hope you all know about alpha. Yeah, it's kind of like this way, I can say. This is what I'll call alpha, okay? Okay, so let me just write the formula. Formula first, and then discussion. Okay, so what I'm going to say is that let's say we have f, the function, and the alpha, which is the scalar. So I'm going to say alpha f x is equal to, what is it going to be? Simple. let me just write it again. Okay, so it's going to be alpha function f x. So just their multiplication, okay, so this was the alpha, which was a scalar, and f was the function, and x is, well, you know, which we're using in all and each and every you know, what are we discussing about? So we're talking about the concepts, so different kind of concepts. Yeah, these all are related to algebra, all algebra, okay? So scalar and the, you know, vector. I was just kidding. Okay, so let's just not include these vector and scalar, just forget about them. Okay, so if like we're having a scalar, so we're just only going to, you know, describe the scalar. We're not going to talk about vector, okay? We're not studying physics for now. So let's just not talk about vector, just only talk about scalar, only for this topic, only for this concept, only for this main, I can say, okay, let's say topic. Yeah, so alpha in function x, so it's actually function f, on which I'm going to say alpha fx is equal to, so you know, so like their multiplication, well, you know, we're gonna do their multiplication just together. So this is what the formula we're having. And one thing that x, each and every, you know, the element x belongs to the set x. So what I'm going to say is that let f be the function, and which is from x to r. Can we say this x to r in this case also? Yeah, we're gonna say. So it's just a real valued function. One thing that is just crystal clear. That's just like for sure. So this is a, you know, real valued function, and the alpha, what we have is scalar. So alpha be a scalar. Okay. Whatever. Okay, so this is a real valued function. Real valued function, and alpha be a scalar. Then what are we going to say? Then, you know, just a scalar means the real number. Okay? So, this scalar actually means it means real number, nothing else. So, the scalar means real number, nothing else. So, a real valued function, so we're doing a multiplication from a real valued function with a scalar. That's it. And the scalar is a real number. So a real valued function to a real number. That's it. What's the difference is that it's a function and it's a number only. Okay? So then what are we going to do? So then what are we going to say? So then the product, as we're doing the multiplication, of course, the product of alpha f is a function we know. Then the product of alpha f is a function from x to r. Just have a look. Then the product of what we're having. So then the product of alpha f is a function from x to r defined by this formula. So this is what we have, the formula. That's it. Okay, so now we're going to talk about a multiplication by, multiplication of two real functions, of course. Yeah, so let's move on to our fourth topic that is about the multiplication of two real functions. Multiplication of two real functions. Okay, multiplication of two real functions. So now we're talking about the real function. So both are the real functions. So let's take this same example, the same thing. Oh, I've drawn a lot of lines. It's kind of looking really messy, like in a trash, looking like a trash. So I'm just gonna wrap this line, so no need to draw these. Okay, whatever. Let's just not talk about it, or else I'll be like just cleaning all the lines. Yeah, so multiplication of two real functions. So multiplication of two real functions, as we're talking about the two real functions and about their multiplication. So I'm going to say that, let f be the function from x to r and g from x to r be any two real functions where x is a subset of r. Just have a look, is this statement is correct, like where x is a subset of r? Just tell me where x is a subset of r. X is a subset of r. Actually, we're not going to say this, that x is a subset of r, because as we're talking about the multiplication. So we're not going to include these things, okay? The subset or the supersets, nothing. Okay, so let me just rub this. Yeah, one thing that I'll say that element x in the case like we're seeing it everywhere. So this will come in this too. So it's a function. So what I'll say is that fg will be from x to r, and which is defined by the formula. I'm just writing it. It's fg x, which is going to be fx and gx, and x belongs to all the x. Okay, is it right? Okay, so fgx, so their multiplication of two real functions is equal to fx, gx, and one thing, the element x. So it's, it's just a symbol. So x is just a symbol. So it's saying that it belongs to x. So this set, to the first set that we're having, and it is x, okay? That's it. Nothing else. So in the multiplication of two real functions, we're going to solve it by using this formula. For the addition, we're going to use this. Subtraction, this one. And if a multiplication by a scalar, then we're going to use this one. That's it. Nothing else. So yeah, what's the difference in the multiplication of these two things? So it's actually that in this case, like we were talking about both of their functions, both of their values, so fx and gx, but in this one it was all merged, okay? As alpha was a real number, so So like we're not going to talk about a function, so we're not going to include this in function, so that's what we wrote here. Okay? Yeah, so let me just let me clean the board, and then I'm gonna write the fifth one, which is gonna be the division. Okay, the quotient. Okay, so let me just clean this all off. It's just going to take a little bit of time. I'll be fast. Almost done. Maybe not. Okay. So now we're going to discuss about the quotient. The quotient, which is just related to the division of two real functions. And the division, like, we'll be having the same functions f and g. And we're just going to look at them in the division form, okay? In the division form. Okay, so fifth one is quotient of two real functions. Okay? Quotient of two real functions. So now we're talking about the quotient that I've told you that we're going to talk about the division. So let us say the formula that I'm first going to write, or should I write first this example? Okay, I'm going to write the example first. Yeah, so f is the function. F is the function, and let's take two sets, okay? We're going to take two sets, x and r, just the same. So I'm going to say let f and g be two real functions. So let f and g be two real functions defined from x to r, where x is a subset of r. X to r, where x is a subset of r. Okay? One thing is that f and g are two real functions defined from x to r, and the second thing is that x is a subset of r. So the quotient of f by g, denoted by, f upon g, is a function. So how am I going to define it? So the quotient of f by g is denoted by f upon g, and f upon g, which is actually in the form of which is actually a function. So in the form of in which we have the numerator and denominator. So by fg is a function defined by. So let me just write, how am I going to write it? So f by g x is equal to fx upon gx, where g is not equal to 0 and x belongs to x. So for all the x we're having, that belongs to the first set. So one thing that we have seen in the denominator, then in the function that whatever, if we're having any fraction kind of thing, so if we're having any division, if as we're discussing about the division, so in which we can see that we have the denominator, but first thing But first thing is that we always have to remember that the denominator is not equal to 0. So it can't be equal to 0. So it's always going to be 1, 2, or, something else. But it's not going to be, so it's not equal to 0. So what I'll say is that G is not equal to 0, okay? Oh, sorry, yeah, I'm talking about the GX, not only the G. GX, yeah. GX is not equal to 0. Okay? Yeah. So, this is the formula for the main, and we have to always remember this thing. That's it. Nothing else. So, see, all those 5 things were really easy to understand. And now let's just move on to our question. So, finally, we're going to do a question. So, let me just write the question. So, what is it? Question is, let F and G be 2 real functions, or maybe let me just write it from another way, okay? In which I'll be first telling about their values. Okay. Yeah. So let fx is equal to under root x and gx is equal to x. So I've written the question. So gx is equal to x, be 2 functions defined over the set of non-negative real numbers, okay? Non-negative real numbers. So what do we have to find? So we have to find f plus gx, f minus g and x, and f g x, and the final one is f upon g x. So we have to find 4 things. So this is the first part, this is the second part, this is the third part, and this is the last 4th part. Okay, let's solve the first part. So we have f plus g x is equal to what? Okay, so first thing, according to the formula, so as we know the formula, so it's just really easy to solve these questions. So these are just really easy questions. So f plus gx. Okay, so first we're going to write fx plus gx, and which is going to be, what is the value of fx? Fx is under root x, and gx is x. So under root x plus x, that's it. Let's move on to our second part. So that's kind of really the piece of cake. Easy to eat. So, just a way easy to solve. So f minus gx. So it's same like this way, just the difference between the plus and minus. That's it. So fx, fx minus gx. Fx is under root x, gx is minus x. So it's actually x and the minus for the subtraction, as we can see. Okay, so let's move on to our third part. So the first and second part was really easy. So let's move on to our third part. Fg x. So fgx, in which we're going to write fx and gx. Okay. So what is fx? Fx is under root x into x. Okay, so now we have to understand something. If I'm going to, if I want to remove this square root, then how will I write this? So I'm going to write this as this way, x by the power, so x to the power 1 upon 2, as we can see simply, as we all know about this in the square root. So, and this will be x to the power 1. Okay, and according to the laws of exponents that we have studied in earlier classes, then the base is common, so we're gonna add the exponent. So what are we going to get? So we're going to get x to the power 3 upon 2, isn't it? So that was like really easy. So just a little bit to understand about it. So now the fourth part we have is f upon g x. Okay, so now the fx upon gx. And one more thing is where gx is not equal to 0. Where gx is not equal to 0. Okay, I'm going to write it again. Yeah, where gx is not equal to 0. One thing we have to remember. Okay, so what's the fx? Fx is under root x. Gx is x. So if I'm going to say, if I have to just remove the square root, what I'm going to write? X to the power 1 upon 2. And this is x to the power 1. And if I want to put it in the multiplication to move it here, just beside this one, so it's going to be x to the power 1 upon 2 division, which has been in multiplication, x to the power minus 1, x to the power negative 1, as we have changed this place. So it was in division, so now it's in multiplication. So, and after this is just like the same case. So laws of exponents say if the bases are same, then, and if the exponents are different, then we're just going to simply add them. And if we're going to add them, this is going to be like plus minus gives us minus. So x, so which is going to be x to the power minus 1 upon 2. That's it. Wasn't it really easy? So just what I did was really simple. Plus minus 1. So it's going to be minus. So 1 upon 2 minus 1. So through this way, we can easily write it. So I've got the answers for both, for all the four parts. So we have solved this question, and through this question, we can be sure that if the topic is clear to us. So if it is, then yes, we have discussed about algebra for real function, and the discussion is just complete. It's now over. That's it. So that's all for today, and in the next video we'll be continuing after this topic. So I don't know if I'm going to solve this, if I'm going to solve some questions with you, or if I'm going to discuss about any other topic. So I don't know what am I going to do. So thanks for watching and have a great day.